Good morning, Integrated 3 class. This is week 3. Week 3 for Integrated 3. We have our weekly assignment rolling up today. It's on exponential functions, and it's a review, you could see, of these two different lessons from the Functions and Data book. That's why there's two PowerPoints, if you ever want to check those out. But it should be covered in one combined lesson that I'm going to teach you right now in this video. I hope this video finds you safe and healthy and well. And let's dive into some exponential functions. Alright, so right off the bat, notice I've got this Desmos calculator up here on the right. That's always recommended. I'm going to remind you that exponential functions are something that looks like this. Y equals x squared. And just so you always know, if you ever see an f of x, a function with respect to x, that's the same thing as y. It's just what goes on the left side. On the right side with exponential functions, it means exponential because there's a 2 up here by the x, and because it increases exponentially. So it starts small, it's a little larger, and pretty soon, it is way gone. That is different than, say, if I had a linear function. If I just had y equals x, for instance. That's a line. Line meaning linear. Exponential meaning going up exponentially. And for each of these, we're going to be using what I sometimes like to call lovingly the BMX function. My old name was Hoffman before I got married. So growing up, everyone asked me, am I related to Matt Hoffman, the famous BMX biker? I didn't know, so I always said, I hope so, and I still do. In this case, BMX doesn't stand for extreme sports biking. It stands for beginning number times the multiplier and then raised to the x power, where the beginning number is also called our start value, and the multiplier is also called our constant multiplier. So the first few questions, we're just going to simply practice writing out what this would look like to plug into our own equation. Now notice it says y equals blank, so we don't need to type y equals, we just need to fill in the blank. And the blank starts with our beginning value, which for us is 19. And for you at home, make sure you put your start value, not mine, because it's probably going to say a different number. Then your multiplier. And then for each of these that do not have something to plug in for x, and you'll know it because they'll say like 6 years or 7 years, what's this? It'll be a word problem. You just stick an x. So for this number one, you just put an x up there. And I'll say right off the bat that I have discovered sometimes there's a glitch where if your constant multiplier is 1, you might have to redo the problem because it might not count it correct because it multiplies the 1 in with the start value, doesn't want it explicitly there. Just, if you miss it, hit redo until you get it right. Same thing with this one. Start value of 20, multiplier of 6, and we just put to the, notice what button I'm pressing, this one right here for the power, to the x power. You can also hit shift 6 anytime you want to get to the power. That's what I did in that Desmos calculator over there, is just shift 6 gets up to the power. Alright, number 3, one more of these before we get into something a little different. So starting value of 4, 0.9, and then we've got an x. Alright, so the first few problems, just practicing writing out in our equation form. Then we're going to table this discussion for another time. Get it? It's a table. Okay, so we want to turn an XY table into an equation, and then furthermore, we also want to match it up with a graph. Well, we got to remember a little bit of algebra to figure out what our start value is. On the left side here, we have x values. On the right side, we have y values. Now, the y-intercept, otherwise known as the start value, is always the y point where x is 0. So in this case, when x is 0, y is 3. So my start value is not 0, it's 3. Then our multiplier, well, we're not given that now. So we have to figure out, okay, what do I multiply from going from top to bottom to get my next bottom term? So 3 times what is 12? 12 times what is 48? 48 times what's 192? And 192 times what's 768? It'll be the same number each time, and maybe out there as you're watching this, you just, bam, comes to your mind because you are super good at remembering your times tables. If you're not, no worries, especially we'll have some with decimals. It'll be tough for even the most mentally math talented out there to get in your head, we can go bottom divided by top in any order. So I can do 48 divided by 12 or 12 divided by 3. They'll all be the same. So I can show you that. I can even do 768 divided by 192. It's always going to give me 4 because it's always going to be multiplied by the same number from top to bottom. So that multiplier is 4. And then once again, I just type in x. Now, to match up your graph, we can go point by point. I want to have it be where 0 is 3, 1 goes to 12, 2 goes to 48, 3 is 192, and 4 is at 768. The first thing I notice is that these numbers from top to bottom are getting larger. Therefore, from left to right, I want to find a graph that starts low and then gets larger, very much like figure 1. Now, I want to make sure that this 768 is in the correct spot. And if I do that correctly, that might be all I have to do here because it's so different than everything else. So like this one, you see when x is 4, I could follow this dot. Is that by 768 on the y? No, you'll notice the y only goes up to 250. So even though the graph is the correct direction, I know it's not figure 1 because this doesn't touch at 768 when x is 4. All right, let's go down and try the next one. Figure 2. Now when x is 4, is y 768? Well, it's a little less than 800, so yeah, maybe. Let's check 3. Is 192? Okay. When x is 3, is it a little less than 200? Yes, so it's probably figure 2, but let's just make sure. So figure 3, that doesn't go up to 768. Figure 4 is going down, notice, from left to right. So therefore, we know it's automatically not that one because it's going the wrong direction. Same thing with figure 5 and same thing with figure 6. So sure enough, it's figure 2. And some of these you can just click, but not this one. In this one, you have to just type 2 for figure 2. And there are going to be quite a few problems like that. So that's just how to enter those. And then you scroll down and hit check. And voila. We're going to get that lovely green check mark up in the top corner. Right here, we know we've gotten it right. And then I could even click, I don't know if you guys know this, but you can just click up here like on number 5. And that'll take me all the way to 5. I don't have to scroll back down and hit next. All right, here's that decimal one I was talking about. Start value across from 0 is 5, and then I could divide 8.5 divided by 5. And it's 1.7. So again, that's bottom divided by top, and it works for any of those as long as you divide it by directly what's above it. And then an x. So now my numbers are decimals, but they're still going up from bottom to top. So I still want to find a graph that's opposite of this one, that starts low and gets higher as it goes on. And I'm going to look for one that 4 is next to 41. Okay, so you'll see this 4 is not next to 41, it's above 80, so that's not it. This one's going down. Figure 4 is by 14 and 16, so nope, that's not 41. Figure 5 is, in fact, a little bit above 40, and figure 6 is going the wrong way, so sure enough, it's figure 5. And again, as you're out there, reminder to, as always, match up your numbers, your graphs. Don't just click on the figure that I just clicked on because you think, oh, I'm just going to copy from Dylan. Nope, we've got different problems, different answers. You're going to get it wrong unless you get lucky. It's a 1 out of 6 chance, about 16% chance you get it right, but overwhelmingly, you're going to get it wrong. All right, number 6 is the first time we have a starting point, a y-intercept of 300, and then it gets lower exponentially. Therefore, people get confused on this because they think, oh, it's getting lower, therefore I'm going to have a negative multiplier. No. We still need to do a number divided by directly what's above it. But you don't get a negative number, you get a decimal. Which makes sense. If I'm multiplying a number by something each time and it's getting smaller, that number that I'm multiplying by has to be less than 1. It's like if I had a shrink ray and I was zapping you and you're getting half as big every time I zapped you with that shrink ray, it would have to be cutting you down by a certain fraction or decimal, in this case a half. And that was the daily shrink ray analogy. Brought to you by movies from the 90s. Movies from the 90s. Still entertaining, but often very dated. All right, we're going to start at 300 now and go down. So this one that's similar to the ones we've just had is the opposite of what we want now. We want one that starts up at 300 and then goes down. So anything that's like figure 1 is not the answer. Figure 2, same way. There's figure 3. we have one that starts at 300. And notice this handy table that stays here. 1 is by 150. 1 is by 150. And then 2 is supposed to be by 75. I'm not even going to check the rest of them. I know it's figure 3 because every single point lined up. Saving myself some time. Being smarter than the problems. And show us that lovely green. Yep, there it is again. And to continue showing that you can do this, I'm just going to click 7 in the top left corner. And it's going to take me right to number 7. Where once again we have a similar problem. 1,000. And then always bottom divided by top. So 500 divided by 1,000. Oh, it's 0.5 again, which makes sense because 500 is half of 1,000. 250 is half of 500, and so forth. And once again, we want to find one that starts really high and goes lower, but no, this one starts at 400. We want it to be 1,000. So it's not figure 2, it's not figure 3. It's not figure 4, it starts at 400. It's not figure 5. Oh, it's automatically got to be figure 6. Well, sure enough, it's the only one that starts at 1,000. Then it goes to 500. Then it goes to 250. So figure 6 it is. Moving right along. All right. Up to this point, you could have probably used your phone calculator, some other little old school elementary calculator you've had around your house. But now we get to excitingly use Desmos for graphing, which is good. So if you really haven't had it up to this point, take a moment and open a new window and get out the Desmos graphing calculator. Because we're going to type in exactly what you see here. Y equals 10 times 4. And then look very closely. The to the X button is right here where there's an A and there's a B above it. And if you don't have this whole menu of buttons, hit this little icon right there. I'll show you. You're going to open it up and it's going to look like this. And you're going to be like, oh, where'd all the buttons go? Just hit this keypad button right there. You'll get all these things. And then the A to the B button right there is the one you want. And we're going to put an X up there. Now when you do, you can see that we have the direction of the graph right off the bat. And it makes sense because our multiplier is not a decimal, it's a whole number. So it's going to be going from left to right, up. So I immediately know it's not this one. It could be the second one. But how am I going to see that? Because this graph is so much larger than what I have here. This one only goes up to 40. So well, I could zoom out. I can hit this little minus button over here. But even that, look at this, a little sketchy. I'm not liking that. I can adjust the X, Y, or I'm going to do something else. There's a little gear button right here. Hit that. And then, of these icons, you'll notice there's a table here. Hit that. Bam! Now all of a sudden, I've got a table. And I want to see, since this graph is going up, this dot appears to be when X is 3. So over here, I'm going to replace this, say, 2 down here. This goes from negative to positive. I can just hit when X is 3, Y is 640. Huh. All right, so let's find one when X is at 3 and Y is at 640. So not that one. That one's going down, that one's going down, that one's not by 640. It better be the last one. Hey, 640. And then when X is 2, Y is 160. 2Y, yeah, it's between 1 and 200. The cool thing about these, even though you've had to do this little extra work in your Desmos calculator, is you can just click on your answer. You don't have to scroll all the way to the top and type in figure 6 or something. You just click on it and check it. And for your hard work, it gave you a lovely message. Superstar, it says. All right? 9 and 10. 9 and 10. So once again, I have a equation. I'm going to type in my Desmos calculator. I'm going to close out of this old one. I'm just going to type it in. Y equals 250 times 0.7 raised to the X power. This one's going down because our multiplier now is a decimal. So maybe it's going to be this one. Well, where's my highest dot now? It's at, I look down, negative. In between negative 2 and negative 4 is negative 3. So I am going to hit my gear button again. Then I'm going to hit my little table button. And I want to know at negative 3. And I also want to know at negative 2. So there you go. Well, let's just do a negative 1 as well. All right. So 728 At negative 3, this goes up to, above 700. Ooh, it might be this first one. At negative 2, it's at 510. Oh my gosh, negative 1, it's at 3. It's got to be this first one. Brilliant. Wow. Look at the second one. It's 250,000? Wow, that's large. Let's skip ahead. It's none of those other ones. Phenomenal. Last one. Remember to type in your equation each time. If you missed one already, you probably learned that the hard way. To the x. All right, it's going up because even though I have a decimal on this one, it's a little tricky. This decimal is greater than 1, so it's getting multiplied by 4.5. That's a number that's going to be getting larger each time. And once again, it starts at 3. So I'm going to do 3. I'm going to say what it is. It's 2. If you're really curious what it is at like 500, oh my gosh, don't do that. That's too large. 20. Oh, that's scientific notation. How about like 8? Oh, that's still scientific notation. What's the smallest number we can get before it gets scientific notation? Looks like 7. So at 7, if you're curious, it's at 298,935.56. We don't care about that right now, though. We just care about matching up 3 with 729. These numbers are getting larger, so from left to right, we want one that resembles this graph, not this graph. So 3 is by 729. Nope, that's only up to 350. That one's going backwards. That's only up to 80. That's going backwards. 729 it is. It's the final one for me. Yay! We got spectacular, phenomenal, and now tremendous. If you went outside today, you might have seen some tremendous trees blooming. Oh, the dogwoods look beautiful in Milwaukee. Okay, there it is. As always, the full correct and points for each question on our example. We're going to see that 100%. And it's dramatically going to show us right now. 120 out of 120 points. Phenomenal. If you finished this, congrats, you're done for the week. As always, if you want more math practice, go into Khan Academy. But you have so much to do in all your other classes right now. You can also just work on those. Send me an email if you want to catch up, if you're missing my class. Otherwise, thank you so much for watching this video. Hopefully it was very helpful. As always, I hope this video finds you safe and happy and healthy and well. This has been Class Away from Class. Much love and best wishes with your week. Take care. Be safe out there.